Mutability. Mutability. So what about mutability? Mutability will get to actual programming real soon now. And first there is one more piece of zero to understand. And we saw that object values can be modified and the types of values discussed in earlier chapter, and such as numbers and strings and booleans, and are all immutable, and it's impossible to change values of those types, by the way, and you can combine them and derive new values from them. And but when you take a specific string value, that value will always remain the same, sorry, and the text inside it cannot be changed, by the way. And if you have a string that contains cat between double quotation, it's not possible, by the way, for other code to change a character in your string to make it spell rat between double quotation. And objects work differently. You can change their properties, by the way, and causing a single object value to have different content at different times. And when we have two numbers, 120 and 120, we can consider them precisely and the same number, whether or not they refer to the same physical bits. And with objects, there is a difference between having two references to the same object. So, and having two different objects that contain the same properties. Consider the following code now. Let object 1 equal value 10, semicolon. Let object 2 equal object 1, semicolon. Let object 3 equal, open parentheses, value and 10, semicolon. Console.log, open parentheses, object 1 equal object 2, semicolon will be true. And console.log, open parentheses, object 1 equal object 3. Yes, it's false. Okay, so object 1 dot value equal 15, semicolon. Console.log, open parentheses, object 2 dot value, semicolon, result will be 15. And console.log, open parentheses, object 3 dot value, result will be 10. Okay, so the object 1 and object 2 bindings grasp the same object, by the way, and which is why changing object 1 also changes the value of object 2, and they are said to have the same identity. And the binding object 3 points to a different object, by the way, and which initially contains the same properties as object 1 but lives a separate life. And bindings can also be changeable or constant, but this is separate from the way their values behave. And even so, numbers value don't change, and you can use a let binding to keep track of a changing number by changing the value the bindings point at. Similarly, such a constant binding to an object can itself not be changed and will continue to point at the same object, by the way, and the contents of the object might change. Like this example now. Const score equal vectors 0 and comma home 0, semicolon. And the result this is okay. And score dot vectors equal 1, semicolon. Result this isn't allowed. The result here is isn't allowed really. Score dot vectors equal 1 and score equal vectors 1 and home 1, semicolon. And when you compare objects with JavaScript equal operator and it compares by identity, it will produce true only if both objects are precisely the same value, and comparing different objects will return false, and even if they have identical properties. There is no deep comparison operation built into JavaScript and which compares objects by contents, but it's possible to write it yourself, and which is one of the exercises at the end of this chapter.